Welcome back to another one of my applications of differentiation videos. We'll be focusing on the mean value theorem, and this is the third episode. Okay, so let's just get cracking into it. So first I'll start with the criteria. So for us to use the mean value theorem, the function has to be continuous on the closed interval of a to b. The function has to be differentiable on the open interval of a to b, and the function of a must not equal the function of b. If it does equal, then you use the Rolle's theorem. The mean value theorem is used when they don't equal, which is basically saying the y coordinates shouldn't equal on these 2 points. Anyway, if all these go good, then you use the formula derivative of c equals the derivative of the function of c equals the function of b minus the function of a over b minus a, and you use this to find the c value, and I'll show you that now. So the function, just the example one, the function we're doing in this video is just going to be x to the power of 3, or x cubed, within the domain of -1 and 1. So what does this function look like? Well, it's actually pretty easy, pretty good, not very troublesome. So that's our function, function of x, which equals y, and this is our x. Now, hopefully I get this right, but this will be 0.1 and this will be -1, and it should come down around here, curve in, and then go like that. So this isn't in symmetry, but in the actual function is symmetrical. So this point is symmetrical to that point, and so on. Anyway, so the points we're looking at are which will be up here, and if we follow this down, it will be down here, which if they were symmetrical, it'd be proper, but it's not symmetrical, so it's not proper. But essentially, I buggered that up, but I'll redraw it. That's good enough. Let's just say here's -1 and here's 1. Okay, this is a dodgy drawing, but it's better than before. So there and there, because we want a line that goes through these 2 points, which is even worse than before. But basically, we have a line going through these 2 points, and we're trying to find the point or points where the slope on this line is equal to this. And because the slope goes around, it goes above and below, there'll be 2 values where the slope is equal to the slope of the secant line passing through it. So this point and this point are c values. This will be c2 and this will be c1. And this slope here will be calculated using that, and the slope of c1 and c2 will be found using this formula. Okay, so let's get right onto it. Okay, so we have a function x cubed. So what we're going to do is first, this is a and this is the b value. A is equal to -1, therefore we sub -1 into the function. Function of a will equal -1, because -1 to the power of 3 is -1. The b value equals 1, therefore the function of b, which means we sub b into the function, and we get 1. Too easy. Now what we do is we find the function of c. So we just replace the x's with c's. So basically c to the power of 3, and then we find the derivative. Derivative of function of c equals 3c squared. Okay. Now the formula derivative of function of c equals function of b minus function of a over b minus a. We have all of them now. Now we can sub them in. So the derivative of the function of c equals 3c squared, and that will equal function of b, which is 1, minus function of a, which is negative 1, over b, which is 1, minus a, which is negative 1. And as you can tell, they equal the same thing. And therefore, the fact that top is equal to the bottom, you just write 1, because it's a whole. And so you got 3c squared equals 1. Divide both sides by 3. You get c squared equals 1 on 3. And what happens is you square root both sides. C equals plus or minus the square root of 1 on 3. Now the reason we do plus or minus, I've explained in a few videos, but not all of them, is that if we were to find c and we had 1 on 3, if we squared that and we got if we squared this, we would get c squared. If we square, I don't know how I'm trying to say this. Basically, if you square a positive number, you will get this. If you square the negative, you will also get this. If you square a negative number, you get a positive. If you square a positive, you get a negative. Therefore, if we're square rooting it, we don't know which one we started with, so we write positive and negative as well. Hopefully that wasn't too complex, or too gibberish, but that's as good as I can do right now. Anyway, so that means that one of the values, we'll say C1 is equal to a negative square root of 1 on 3, and the other value, C2, is equal to positive square root of 1 on 3, because there's two values. Okay? Because if we squared this value, we would get 1 on 3. If we squared this value, we would also get 1 on 3. Therefore, we have a positive and a negative value that could be that could be the answer to C. And as you can see here, we're in negative x, and we got in positive x, which makes sense. So we have two values because we have two C points. It makes sense. Okay, and basically that is it. So C1 is negative square root 1 on 3, and C2 is positive square root 1 on 3. And at those 2 points, the slope at those 2 points is equal to the line that passes through. It's equal to the slope of the line that passes through the points at A and B. Okay, so I hope this video helped you understand the mean value theorem. Thanks for watching and have a good day.